Hello everyone, today we're playing Calculus AP Edition, and today we are doing the AP Calculus AB 2024 Free Response Question 5. Alright, this one is a pretty hard one, I can't lie. It definitely was very hard during the test as well, I'm not gonna lie. But if it's doable. Alright, so let's start with part A. Alright, so point near the curve near 25. Alright, next coordinate 3. Use the line tangent to find point. Okay. Alright, so this is tangent to the curve, so we gotta find the equation. Thank God they solved dy over dx for us. So let's put those points in. So let's do dy over dx, big line, and put those 2 points, do those 2 coordinate points, because really we're trying to find. What we're trying to do is we're trying to find the tangent line for these coordinates, and then input 3 at the end. So, alright, so we got that. So it's going to be -4, 3 plus 4y, so it's going to be this. Alright, there we go. Alright, we found the slope. Good job. So, let's make our y. We don't have to find y because they already gave it to us. Alright, so let's do -14, 19, x minus 2 plus 4. Alright, and then so you're going to want to do this. No, you don't want to do that. So you're going to want to put something like here, squiggly line, y approximately equals you want to input that 3 right there, and after this you don't want to touch it. We don't really have calculators. You can do this, oops, you can do it with the like after, but just leave it like this. Whatever you do, just leave it like this. Okay. Alright, so that's part B done. Alright, is the horizontal line. Alright, let's part B. Horizontal line, y equals 1, tangent to the line. Well, the way I solved this back then is I tried to just inputting it, and it definitely works. It's a method that works. Alright, so input 1 to this right here. Alright, so I'm not going to worry about anything else, just input y. So plus 3 plus 2 equals 48. Alright, and that's going to be x equals 43. Now you're going to have to do the plus or minus. Let me focus it for you guys. Yeah, okay. Alright, there we go. Alright, so we got this value now. Pretty crazy. So, to make sure that this horizontal line, that means dy over dx is 0. Now, we could ignore the bottom part, because if that's 0, then that means it's undefined. So let's go to dy dx 40 plus or minus 43 of 26. Alright, you're gonna notice there's no way that this is ever gonna be 0. And so you can just do this, now equals 0. And put, like, since it asks you for a reason, therefore y equals 1 is not tangent to the curve. Alright, I think that's a pretty good response. I mean, it's pretty simple, pretty good. It tells you what's up. You could put at. Yeah, I mean, that can make it a little better. Alright, C can confuse you if you don't know what you're doing. So it gives you the coordinates. It's asking you, is this point vertical? Alright, if it's vertical, it's vertical, that means this has to equal 0. So let's put it in terms so you can understand. This must equal 0. Now let's input the y value here, and that's just going to be 0. Y value 0. And so 3 doesn't equal 0. Right here. Boom. So the line curve is not vertical because, and you can put something like dy and then y equals 3, I mean as you were, y equals 0 doesn't equal y equals 0, 3 plus 4 doesn't equal 0, and boom, something like that will suffice. All right, time for part D. Part D. Now it's literally a completely different FRQ. I don't know why they do this, but let me solve it for you right here. All right. You know what? Let me start a new page. So, of course it's ripped. Alright, we got a new page. I'm running out of pages. Alright, so last question. 5D. Alright, so for time greater than 0, a particle is moving along a curve by the equation. Okay. The instant that particle is at the y-coordinate of this particle's position is decreasing at rate. Alright, so this looks like a related rates problem, doesn't it? Alright, so it tells us the y-coordinate of the particle's position decreasing. Alright, so when you see decreasing, think minus. So this looks like a related rates problem. So y-coordinate. So let's put like dy dt equals -2. Okay. And at that instant, it gives us the coordinates. What is the rate of change of x coordinates? So it's asking us to find dx over dt. That's really what it's asking us to find. All right. Only one way to find it. Let's differentiate all of this. All right, so derivative of that equation, so that's going to be 3y times dy over dt plus, all right, we're going to have to use the, since these two are two together, we can't just do it normally. So it's 2 dx dt. It's not just 2 because we are differentiating in terms of dt. Okay, we got this times y plus 2x times dy or dt. Almost wrote dx there. Equals 0. All right. So let's get all the dx's. Well, there's really only one dx. Let's get this dx in one side. So let's move that to here. So it's going to be negative 3 dy over dt. And then that's going to be minus 2x dy over dt. And what's going to be left over is just the 2 dx dt. Okay. And so what you're going to want to do here is, well, this is really just, you're going to divide by 2. You don't have to do that, but I think it's better that way. Minus 2. Alright, and then you're just going to want to input on the y's, just input these coordinates for the dy's. You're going to want to input this right here, and that's all you're going to want to do. So dy is negative 2 minus 2 for negative 2 all over 2, and you're just going to want to leave it like that. Don't touch it, because you're most likely gonna make a mistake, because you're gonna be like, oh, you're gonna be all jittery. So yeah, that's our answer, and thank you for watching. I'll be back with the final FRQ number 6 soon.